This is a demonstration of question 10 from class today. We've been given this function, acceleration, as a function of the velocity of a particle. It's a linear motion, and we were told that initially the body is at rest, so v0 equals 0, and at the origin, x0 equals 0. So the strategy for this one is to write acceleration as the time derivative of velocity, and I'm going to write this as 900 minus v squared over 60 using a common denominator of 60. I can now take the reciprocal of both sides, 60 over 900 minus v squared, separate the variables, and take an indefinite integral of both sides. The integral of dt is t. This one will be better off factorising the denominator and writing this as 60 over 30 minus v, 30 plus v, and there I've used the difference of two squares factorisation, 30 squared minus v squared, 30 minus v, 30 plus v. So now I have to take this integral. I notice there are two linear factors here. I notice also that the numerator is a constant, so the numerator is of lower order. The denominator was a quadratic. Therefore, I'm going to use partial fractions. So just as an aside, I will write my integrand 60 over 30 minus v, 30 plus v, as some fraction a over 30 minus v plus a different constant b over 30 plus v. Writing this under the as a common denominator now, 30 minus v, 30 plus v, I would have a multiplied by 30 plus v, b multiplied by 30 minus v. Clearly the denominators are the same, the numerator must be the same as well. So there's a few strategies. I could equate this I could expand here, collect like terms, and then equate the two numerators. I'd get two equations in two unknowns, the a and b. Or I could take the strategy of eliminating one of these at a time by picking a certain value for v. So my numerators, I have 60, and if you think it's 60 plus 0 times v, if you really want to think about that as a linear term. Over here we have a outside 30 plus v plus b outside 30 minus v. Now v is a variable. V can take any value we like. If we choose to let v equal 30, then clearly the left-hand side of this is still 60. V equals 30, we'd have 60 times a, and v equals 30, this part would be nothing. So that implies fairly quickly that a must have equaled 1. On the other hand, if we choose to let v equal negative 30, the left-hand side, it's still 60. Negative 30 added to this would make this term 0, and over here we would have negative 30 minus negative 30 is add 30. This would be 60b. That implies that b also equals 1. So our partial fractions would be 1 over this, 1 over this, and we can replace this integrand now with something much, much better. So if I just stop and call that equation number 1, I've done the aside to figure out what the integrand should be replaced with, and now I will go continuing from equation 1. T would be the integral of, and as I say, instead of this integrand, I'll write 1 over this plus 1 over this. 1 over 30 take v plus 1 over 30 plus v, and all of that being integrated with respect to v. That's an easy enough integral to do. This would be the ln of 30. Take v. Remember, we have to divide by the derivative of this term here. That's -1. Dividing by -1 has the effect of making that whole thing negative. The integral of this is ln 30 plus v. Dividing by this derivative is divided by 1, which has no difference, plus the constant of integration. Now we can evaluate the constant of integration when we remember that the object was at rest at the origin. So we will substitute t equals 0 and v equals 0. Negative ln of 30 plus ln of 30 plus c. Clearly c equals 0, which means my final statement for this one is that t equals, now the c is 0, it's ln 30 plus v minus ln 30 minus v. I'll need to go over the page. Using log rules, t would be the ln of 30 plus v over 30 minus v. Writing this in exponential form, e to the power of t would be 30 plus v over 30 minus v. Multiplying through, and expanding, 30 times e to the power t minus v times e to the power t. Now I'll collect all the terms with v over here on the left-hand side. Actually, I might move v to the other side. I'll have 30 e to the power t, bring the constant of 30 over, move this term, v times e to the power t plus v, just avoids a few more negatives that way. So I now have v factored out of e to the t plus 1. Here I could factor out 30 from e to the t minus 1. Pretty clearly, I think we can see that v will be 30 e to the power t minus 1 over e to the power t plus 1. And there is our solution for velocity as a function of time.